Welcome to tutorial 10 of the Foundation Theory radio course. In this tutorial we're going to discuss using an SWR meter. You don't have to know much about standing waves at all for your foundation license. So I'm going to spend a few minutes just talking about standing waves with you to give you some background, but you will not be assessed on that material. You do not have to understand what standing waves are, but you do have to know how to measure them and why you measure them. This slide shows the amplitude modulated transmitter that we were discussing a couple of tutorials ago, so you should have a pretty good idea how it operates as a block diagram. And I've added two more stages now. I've added an SWR meter and an antenna tuner. We'll be going to be talking about the antenna tuner later. This tutorial we're mostly going to focus on the standing wave meter. What I want to speak just briefly about is what standing waves are, why are they created, and how do we measure them. To enable maximum transfer of power from the transmitter to the antenna, the impedance or resistance, if you like, of the transmitter and the antenna should be the same. That's not often the case. Often the impedance of the transmitter is always 50 ohms because it's designed to be 50 ohms by the engineers who designed the transmitter. But often our antenna is not 50 ohms, and something unusual happens when a transmitter is connected to any antenna which is not equal to its impedance. And that unusual thing is standing waves. And I'm going to explain that very, very briefly to you. You will not be assessed on it though. When we transmit a wave, a radio wave from a transmitter, which is not connected to its own impedance, in other words, this is not 50 ohms, we get a wave coming from the transmitter. It's a sine wave. We get a wave coming from the transmitter traveling to the antenna. And that's called the forward going wave. That's the wave we're sending from the transmitter to the antenna. This is your wave that you want to transmit. If when the wave arrives, it finds out that the impedance here is not the same as the impedance of the transmitter, some of our forward wave will be transmitted and some of it will be reflected back to the transmitter, and it won't be in phase with the wave that created it. So there's the reflected wave. Bit rough, but this is going to give you ideas. So the blue line is the forward power or wave coming from the transmitter to the antenna. Some of it is radiated, some of the forward wave is reflected, and I've shown that in red, and that's the reflected wave traveling back to the transmitter. Now, when you have two waves traveling in two directions, the forward wave is traveling towards the antenna, the reflected wave is traveling from the antenna towards the transmitter. When you have any two waves like that, it doesn't matter whether they're ocean waves, sound waves, or whatever, these two waves interfere with each other to produce a third resultant wave, and that third resultant wave is called a standing wave, and I'm just drawing it underneath. But it's a standing wave. It's called a standing wave because it doesn't move. These waves are moving from the transmitter to the antenna, from the antenna back to the transmitter. The interference, that pattern they produce, is called a standing wave, and the ratio between the peak of the standing wave and the trough of the standing wave is called the standing wave ratio. That ratio there, so if that was 10 volts, say, and this was 5 volts, then that ratio is 2 to 1, so the SWR would be 2 to 1. And the SWR is 2 to 1 because we know the transmitter and load impedance, and that ratio is also 2 to 1. that's a quick explanation of what standing waves are. We need to know that we have to measure them to find out if our antenna is a close impedance match to our transmitter. If the antenna were 50 ohms, then we wouldn't have any standing waves at all. An acceptable standing wave ratio is 1.5 to 1. It's a fool's errand to try and reduce the standing wave lower than that, because the difference between 1.5 to 1 and 1 is almost nothing. So we need to measure SWR to be able to calculate or determine the match between the transmitter, which is nominally 50 ohms, and the transmitter. If the SWR is very high, it means that we're going to have extra losses in our antenna system, or there could even be a fault in our antenna system. So it's very much to our advantage to know what the SWR of our antenna is. Here is a typical SWR meter. I'm just going to run through the controls on it quickly, because most of them you don't need to know. This is it's a power meter as well, so it can be set to measure 0 to 20 watts here, 0 to 200 watts in this position, and 0 to 2000 watts in the top position. That is actually not part of the SWR meter. You don't need to use that. This control is simply whether we want to measure average power or peak power. So these two really don't have anything to do with the functioning of the SWR meter. If you want to use power, you put this switch onto power, and then this is a power meter. Okay, how to measure SWR? Well, the first thing you've got to do, because you're going to transmit to measure SWR, so the first thing you're going to do before you transmit is check the frequency is clear. If you're not sure, you're going to announce your call sign and you're going to say testing, because you're going to transmit and measure your SWR. The next thing you need to do, you've probably made the announcement on single sideband, you now need to change to a mode that has a full carrier. Single sideband is suppressed carrier. You need a mode that's going to transmit power when you're not speaking into the microphone. So you could use amplitude modulation, that's double sideband. You could use CW, or you could use, that's Morse code, or you could use FM. Any mode that will give you a continuous carrier. You don't want to be talking, you just want to transmit a continuous carrier. So assuming you've done protocols prior to transmission and your SWR meter is connected between your transmitter and your antenna, your next step is to move this switch to the calibrate position. That's a CAL. So we've moved this switch to the calibrate position. We've already announced our call sign, so we're going to transmit the carrier, and we're going to do that on AM, that's double sideband, not single sideband. We could do it on CW, Morse code, or we can do it on FM, because that would give us a carrier. And 3, we're going to adjust the calibrate knob here. So we're transmitting. This knob is on calibrate, and we adjust the calibrate knob to this needle. The SWR meter needle comes all the way over to calibrate. See calibrate on the scale there? So we're transmitting. This is on calibrate. When we first transmit, the needle might only come up to here, so we adjust the calibrate knob so that the needle goes all the way across full scale to the calibrate position. There's the cal on the meter there. So you've done that. The only thing left to do, number 4, switch to SWR, and take the reading. So you're still transmitting, you were on the calibrate position, you did adjust this for full scale, you're still transmitting. While you're transmitting, you move the switch down to SWR and you read your SWR off the top scale. That would be 1 to 1, 1.5 to 1, 2 to 1, 3 to 1, and so on. Infinity up here, and a good SWR is 1.5 to 1 or less. The other type of SWR meter is called, and it's the meter that's shown on the slide, and it's also the meter that I would recommend that you buy if you're going to buy an SWR meter, power meter. It's called a cross needle power meter. SWR meter, I'm sorry. It's both. It's an SWR meter and a power meter. And the beauty of this type of power meter, the cross needle, is that there are no adjustments. In the earlier SWR meter, we had to calibrate it. This type of SWR meter requires no calibration. So that would be going to our antenna. There's a connector on the back, and this would be going to our transmitter. And you simply connect it in after your transmitter. Your ATU would be next, and then your antenna. Have a look at it. It's got two needles on it. One needle here and another needle there. And it's got three scales. It's got a scale here which is your forward power. Remember we discussed the forward power from your transmitter. And this is the reflected power from the transmitter. So this needle will move to measure the reflected power. This needle will move to measure the forward power. Where the two needles cross, suppose this needle came up to 120 watts. And suppose this needle came up, that's not a good example. Let me just undo that. Let's suppose this needle came up to there, and the reflected power needle came up to there. Then can you see the SWR is, I think it's 2.5 to 1. Where the needles cross is your SWR. No adjustments, just plug it in, set your power range, decide whether you're going to measure average or peak power. If you're measuring power, set your power range, no adjustments, transmit, measures your forward power, measures your reflective power. Where the needles cross, there is your SWR. What a lovely SWR meter, a cross needle SWR meter is. Just remember that for the foundation, 1.5 to 1 SWR or less is an acceptable or good SWR. All right, well that's it for standing wave meters for the foundation license. Thanks for your attention. I'll catch you in the next tutorial. Hope you're enjoying the course. Cheers for now. This is Ron for K2DQ for Radio and Electronics School.